Mangaroos Tutoring Services, Mathematics Classes.
Okay, so hi everyone. Today we're going to look at an introduction to indices, or exponents or powers, many different words for it. So this will just be an introduction to what they are, how do they work, how we can use them, how to solve questions involving indices, and the video after this will take a look at the laws of indices. So this just a basic introduction, so let's just get into it. First off, what is an index? Well, here's the definition. An index, or plural indices, is a number which indicates how many times another number, which is called the base, is multiplied by itself. We say the base is raised to the power of the index, and we write it in this form. Base here, and the index is like a superscript. So this form is known as index form, and it is a way to write products of factors. So a base raised to an index, again, is called index form. The index can also be called an exponent or a power. So here's an example. 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. So this is 2 multiplied by itself 5 times. Can be written in index form as 2 to the power of 5 or 2 raised to the power of 5. That's how you would say it. Right? And as you can see, it's a very condensed form of this multiplication here. So it saves us a lot of time when it comes to writing what we mean. So this index here indicates how many times 2 is to be multiplied by itself, and we say again it is 2 to the power of 5 or 2 raised to the 5th power or 2 to the 5th power or 2 raised to the power of 5. Many different ways that you can say it. And of course in this case 2 is considered our base and 5 is considered our index. And as I said earlier, the index can also be known as the power or the exponent. So that's just a bit about indices before we begin looking at examples. So let's take a look at some examples now. Okay, so we have 5 examples here. The question asks us to find the integer value, meaning the numerical value, equal to the following numbers written in index form. So let's begin to expand these numbers according to what we know about indices. So we have our first one where the base is 4 and the index is 3. This means that 4 must be multiplied by itself 3 times. Now, how do you actually evaluate this answer or find the value of this answer? That's what evaluate means. What we're going to do is we're going to multiply from left to right. So we're going to take 4 times 4, which you should know from your times tables is 16. And now we have another times 4 here. So that's 16 times 4, which you can work out manually on the side or with a calculator. But 16 times 4 is 64. And that's your answer for the first example. For example 2, we have 3 squared, or 3 raised to the power of 2. So this is going to be 3 multiplied by itself. And 3 times 3, again from your times tables, is 9. Next, we have 2 raised to the power of 4. So this is 2 multiplied by itself, 4 times. 2 multiplied by 2 multiplied by 2 multiplied by 2. And I'm going to write each step out as I multiply from left to right. So 2 multiplied by 2 is 4. Then I have 2 more. 4 multiplied by 2 again is 8. And lastly, 8 multiplied by 2 is 16. So whatever I do not operate on, I just bring to the next step. So this 2 plus 2, 2 multiplied by 2 comes here. And the 4 multiplied by 2 is evaluated here. And then we have another times 2 that we bring over. So 8 times 2 again is 16. Okay, next for example 4, we have 5 raised to the power of 3. So this is 5 multiplied by 5 multiplied by 5. Now 5 multiplied by 5 is 25. And now we consider 25 multiplied by 5, which again you can work out manually or with a calculator. 25 multiplied by 5 is 125. And lastly, we have 3 raised to the power of 4. This is 3 multiplied by itself 4 times. So 3 multiplied by 3 multiplied by 3 multiplied by 3. Now 3 times 3 is 9. Then we have multiplied by 3 multiplied by 3 again. 9 times 3 now is 27. We still have to multiply by 3 again. 27 multiplied by 3 is 81. And these are your first 5 examples. Now we're going to take a look at some questions. So it is at this point I will encourage you to replay if you need the examples repeated, or when you move on, try the questions yourself before you look at the solutions. But we're going to take a look at the solutions now. So I'm going to move to the next screen. And at this point, you can pause and try the questions yourself, or just look at the solutions. So let's look at the solutions now. Okay, so for this first exercise here, same instructions, find the integer value equal to the following numbers written in index form. So we're going to start with the first question, which is 4 squared. Now this is 4 multiplied by itself. 4 times 4 is 16. And I'm writing the answers vertically so you can see each step clearly. For question 2, we have 3 to the power 4. Now this was an example, but I would just like to show it to you written out vertically. So this is 3 multiplied by 3, multiplied by 3, multiplied by 3. Now I'm going to show each step, multiplying from left to right. 3 multiplied by 3 is 9. And then, as I was explaining before, we bring down each of the 3's that we did not operate on as yet. Now for our next line, we have 9 multiplied by 3, which is 27. And we bring down this last times 3 here. And finally, 27 multiplied by 3, as we know from the examples, is 81. Now again, you can work these out manually, you can use a calculator, whichever one. For question 3, we have 6 to the power of 3, or this is also known as 6 cubed. So 6 cubed is 6 times 6 times 6. Multiplying from left to right, 6 times 6 is 36. So now we need to look at 36 times 6. 36 times 6 is going to be 216. That's your answer for question 3. On to question 4. We have 7 cubed now. That is 7 multiplied by 7 multiplied by 7. Multiplying from left to right, now we have 7 times 7 is 49. And 49 times 7 is 343. So this is our answer for question 4. For question 5, we have 5 to the power of 4, which is 5 multiplied by 5, multiplied by 5, multiplied by 5. 5 times 5 now is 25. Bring down the rest of the sum. 25 times 5 is 125. Again, bring down that last times 5. 125 multiplied by 5 now is 625. So this is 5 raised to the power 4. Your answer for question 5 is 625. Now for question 6, 2 raised to the power of 8. So that means 2 multiplied by itself 8 times. Let's write that out. 2 multiplied by 2, 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 multiplied by 2. So let's just count to make sure that we have the correct number of 2's. 1, 2, 3, 4, 5, 6, 7, 8. Good. So now we start multiplying from left to right. 2 times 2 is 4. And yes, I'm going to bring down everything else still. So we're going to work these out, but I am just going to copy and paste them. Alright, we're going to work these out step by step still. So now let's do 4 multiplied by 2, which is 8. And now we have 5 2's left to operate on. Right, next we have 8 times 2, which is 16. Four 2's left now. Sixteen times 2 is 32. Three 2's left. Thirty-two times 2 is 64. Bringing down this remaining pair of 2's. 64 times 2 is now 128. And we're left with 128 times 2. So our final answer is that, which is 256. So that means 2 multiplied by itself 8 times, or 2 raised to the power of 8, is 256. So let's see how indices can help us in number sentences. So we're going to look at a question with multiple bases raised to various different indices. Okay, so let's take a look at this example. It says to find the integer value, or evaluate, equal to, and we have multiple bases raised to multiple indices. So the first thing we have is 2 cubed multiplied by 3 squared, and then we have multiplied by 5. So what I'm going to do is expand this number sentence just so you can see it visualized, so you can visually see what it is this question is asking you for, but by no means do you actually need to expand to solve this. So first, we will look at 2 cubed, which is 2 multiplied by 2 multiplied by 2. And then we put our multiplication sign. 3 squared is now 3 multiplied by 3. And then we multiply by 5 finally. So 2 multiplied by 2 multiplied by 2 we know is 8. 3 multiplied by 3 we know is 9. So you can do this in pieces as well. And then we have a multiplied by 5. Now, from your times tables, 8 times 9 should be 72. And so we have 72 multiplied by 5, again multiplying left to right as we did before. 72 multiplied by 5. Now when you have to multiply an even number by 5, my trick is really just to divide this number by 2. So 72 divided by 2 is 36. Then you multiply it by 10, which we know is just adding a 0 or shifting your decimal points to the right. In this case, we add a 0. So 72 multiplied by 5 is 360. Of course, you can also use a calculator for this. So this was your example. Let us take a look at a few questions on these now. Okay, so we're going to look at these 4 questions, again, trying to find the integer value of these. Now, before I show the solution, feel free again to pause the video, try the questions yourself, and come back to see if you got the questions right. Or you can continue looking. I'm going to go through the solutions now. Okay, so for question 1, we have 4 squared multiplied by 3 cubed multiplied by 2. So that is 4 times 4. I'm going to expand it. 4 times 4 multiplied by 3 times 3 times 3 multiplied by 2. Now 4 times 4 we know is 16. 16 multiplied by 3 times 3 times 3, which is 27. So now we have 16 multiplied by 27, and we can't forget that times 2. So we can use our calculator for this. 16 multiplied by 27 multiplied by 2 gives us 864. Right, of course you can work this out manually using long multiplication. Just take it step by step. So multiply 16 times 27 first, then 20, and then your answer by 2. Right? Of course you can also do 16 by 2, then multiply by 27, or you can do 27 by 2, then multiply by 16. The order for multiplication really does not matter. Moving on to question 2, I'm going to expand again, but as I said with the example, the expansion is not necessary. You can work each individual order out first, or index or exponent out first, before multiplying from left to right. But I'm going to expand just so you have a visual. So 2 raised to the power of 5 is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. And 6 squared is 6 multiplied by 6, and we have multiplied by 4. So 2 raised to the power of 5 we know is 32. 6 times 6 is 36. Then we have multiplied by 4. So 32 times 36 multiplied by 4 is 4,608. So this is your answer for question 2. Moving on to question 3. Question 3 tells us 8 squared, which is 8 times 8, multiplied by 2 to the power of 4, which is 2 times 2 times 2 times 2, multiplied by 9. So we write that over. So 8 times 8 we know is 64. 2 to the power of 4 is 16. Then we have the times 9. So now we multiply 64 by 16 by 9. This is 9,216. Again, work it out manually, work it out with a calculator. Either way is fine. Let's move on to question 4. So for question 4, we have 10 multiplied by 14 squared, which is 14 times 14, multiplied by 2 cubed, which is 2 times 2 times 2. So we write over 10. 14 times 14, or 14 squared, is 196, and 2 cubed is 8. So we have 10 times 196 times 8. The order in which you multiply does not matter, but your answer should be, when you multiply, 15,680. And that is your answer for question 4. So now let's move on to a discussion of negative bases. So what happens when the base has a negative sign attached to it? Let's look at that. Okay, so all of the examples before dealt with positive bases. So now we're going to deal with negative bases. which is when the base, not the index, but the base, which is a number that has to be multiplied by itself, when that number specifically is negative. Now, let's take a look at these examples. Remember, with indices, the index tells us how many times we must multiply the base by itself. So for this example, minus 1 to the power of 1 is just minus 1. Minus 1 to the power of 2, or minus 1 squared, is going to be minus 1 multiplied by minus 1, which is going to give me positive 1, right? Due to our directed numbers rules, negative multiplied by negative is going to give you a positive. Minus 1 raised to the power of 3 now, we'll have minus 1 times minus 1, which we previously saw was 1, but then 1 times minus 1, because it is a positive number multiplied by a negative number now, the signs are different. That means that our answer is going to be negative, so we're going to have negative 1 for our answer. Now, for minus 1 raised to the power of 4, we're going to have minus 1 multiplied by minus 1, multiplied by minus 1, multiplied by minus 1. So we already know that minus 1 times minus 1 times minus 1, which is this up here, is equal to minus 1. So minus 1 now, multiplied by minus 1 again, is going to give me a positive 1. So that's a little interesting. Let's look at the rule applied to negative 2. So negative 2 raised to the power of 1, again, is just negative 2. Right? So the number raised to the power of 1 is really just itself. Minus 2 squared now is going to be minus 2 multiplied by minus 2, which is going to be positive 4. Again, a negative by a negative. The signs are the same. Your answer is going to be positive. Minus 2 cubed, however, would be minus 2 times minus 2, which we realized before was 4. 4 now times minus 2 is minus 8. So minus 2 cubed ends up being a negative number, negative 8. And finally, for minus 2 to the power of 4, we have minus 2 multiplied by minus 2 multiplied by minus 2 multiplied by minus 2. And minus 2 multiplied by minus 2 multiplied by minus 2 is equal to minus 8. Minus 8 multiplied by minus 2, again a negative times a negative, is going to give you a positive. And 8 times 2 is 16. So what we notice is that if you have a negative base and you raise it to an odd power, your answer is going to be negative. If you have a negative base and you raise it to an even power, your answer will be positive. Right? So between odd and even, the answers alternate between negative and positive. So odd is negative, even would give you a positive. Odd, negative again, even, positive. So now let's look at some examples. Okay, so our first example is negative 2 raised to the power of 4. So again, I'm going to expand it just so you can see what it looks like. So this is negative 2 multiplied by itself 4 times. So minus 2 multiplied by minus 2, multiplied by minus 2, multiplied by minus 2. Right, and I'm going to do it step by step as well. So minus 2 by minus 2 is going to be positive 4. Bringing down my pair of minus 2's. So now we do 4 times minus 2, which is minus 8. Positive number times a negative number is going to be negative. And bring down our final multiplied by minus 2. Minus 8 times minus 2 now, two negative numbers multiplied by each other, it's going to give me positive 16. And so that's how we get a positive answer for minus 2 raised to an even power. So that's our first example. On to our second example. We have minus 2 raised to the power of 4. Now this example here, number 2, it looks very, very similar to question 1, but it is actually not the same. So the brackets here actually makes a difference. These brackets are telling us that we want to take minus 2 and multiply it by itself 4 times. Without the brackets, what we can think of it as, and I'll write it down, we can think of it as minus 1 multiplied by 2 to the power of 4. Now this is because of BODMAS. When we think of it as minus 1 by 2 to the power of 4, if we look at the letters of BODMAS, orders, which is your exponents, must be done before multiplication. So 2 to the power of 4 must be evaluated before we multiply this number by minus 1. So let's do that. We know that 2 to the power of 4 is 16. So minus 1 multiplied by 16 is minus 16. We have a positive number multiplied by a negative number. And that is the difference. Notice that our answers are different. We have 16 for example 1 and minus 16 for example 2. And that is all because of the presence or the absence of the brackets. So let's look at another example. So this one, example 3, says minus 2 to the power of 5. Right, so this is going to be equal to minus 2 multiplied by minus 2 multiplied by minus 2 multiplied by minus 2 multiplied by minus 2. And well, I know that this power is odd, so my answer should be negative. And I know that 2 to the power of 5, so 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So I know my answer is minus 32. But for question 4, or for example 4 rather, we could think of this as minus 1 multiplied by minus 2 to the power of 5. So just to state the question, we have minus 2 to the power of 5. That's minus 1 multiplied by minus 2 to the power of 5. And we know that minus 2 to the power of 5 is, from example 3, that's equal to minus 32. So we have minus 1 times minus 32, which is a negative number multiplied by another negative number. So that should give us positive 32. And that's your answer for example 4. Now there's a little note here that says, take note of the effect of the brackets in the above examples. So as I said, the presence or the absence of the brackets actually can change the value of your answer, right? Specifically the signs. So let's take a look at some questions, which again, you can pause the video, try on your own, and then take a look at the solutions. So these are the 6 questions that we're going to do now. Go ahead and try them on your own or just take a look at my solutions. Okay, so let's take a look at question 1. We have to evaluate or find the value of minus 1 to the power of 5. Now I'm going to write this first one out just so you can see. Minus 1 multiplied by minus 1 multiplied by minus 1 multiplied by minus 1 multiplied by minus 1. Now, I don't have to spend my time working each pair. What I can do is just recognize that this power is odd. It's a negative 1 being raised to an odd power, so you're going to end up with a negative 1 for your answer. Right? If it were an even power, like in question 2, you would see that it's a positive answer, right? So for question 2, I'm not going to expand it. Again, you can just recognize that it is an even power, which means that we'll end up with positive 1 for your answer. So minus 1 raised to the power of 8 is going to be positive 1. For question 3, we have minus 3 raised to the power of 3. So this is minus 3 multiplied by itself 3 times. Now, because we have a negative base and an odd power, we know our answer is going to be negative. So I'm going to put that here, but just so you can see me work it out, minus 3 times minus 3 is positive 9, because a negative by a negative is a positive. Now 9 times minus 3 is going to be negative 27. So 9 times 3 is 27, answer is negative. But we could have just done 3 cubed and said that our answer was negative because the power here was odd. So 3 cubed being 27, and because it's a negative base raised to an odd power, your answer is also negative. Now let's look at question 4. Now there are no brackets here, which means that we need to think of this as minus 1 multiplied by 3 cubed. We know that 3 cubed is equal to 27. So this is minus 1 multiplied by 27, which is minus 27. For question 5 now, this is minus 6 squared. So this is going to be minus 1 multiplied by minus 6 multiplied by itself. So minus 6 multiplied by minus 6. So we can multiply left to right. Minus 1 times minus 6, two negatives multiplied by each other is going to be positive 6 multiplied by negative 6. Negative by a positive is going to be negative, and 6 times 6 is 36. Now you could have also multiplied minus 6 by minus 6 and gotten positive 36, then multiplied by minus 1 to get negative 36. So again, the order does not matter for multiplication. So the order in which you do the multiplication does not matter. You'll get the same answer. Okay, so for question 6, we have minus 1 to the power of 6. So you can think of this as minus 1 multiplied by minus 1 to the power of 6. And we know that since this is a negative base and an even power, my answer is going to be positive. So 1 to the power of 6 is really just 1. And I will have minus 1 multiplied by 1, which is minus 1. So your answer is negative 1 for question 6. And these are your answers for questions 1 to 6. Let's move on to another exercise, which again you can pause and try on your own before I go through the solutions, which will be now. Okay, so let's take a look at question 1. This instruction tells us we need to expand the following and then evaluate. So as I would have said before, it's not necessary to expand, but this question specifically asks us to. So we need to expand these indices. So 2 to the power of 4 is 2 multiplied by 2 multiplied by 2 multiplied by 2. 3 to the power of 3 is 3 times 3 times 3. Then we have minus 1 to the power of 5. So minus 1 multiplied by itself 5 times. Right? Now we know that 2 to the power of 4 is 16. 3 to the power of 3 is 27. And minus 1 to the power of 5 is going to be minus 1. Again, because negative base and odd power means we have a negative answer there. So we have 16 multiplied by 27 multiplied by minus 1, which gives us minus 432. Again, work it out manually or use a calculator. Either one works. Let's move on to question 2. So question 2 says 5 cubed multiplied by 3 squared multiplied by minus 2 cubed. So this is 5 multiplied by 5 multiplied by 5 multiplied by 3 multiplied by 3. So 3 2 times. Multiplied by minus 2 multiplied by minus 2 multiplied by minus 2. Right? So we know that 5 cubed is 125. 3 squared is 9. And minus 2 cubed, again, a negative base raised to an odd power is going to be a negative result. So minus 2 cubed is minus 8. And let's work this out. 125 multiplied by 9 multiplied by minus 8 is minus 9,000. And this is your answer for question 2. Now for question 3, we have 3 multiplied by minus 2 squared, so that's minus 2 times minus 2, multiplied by 4 cubed, which is 4 times 4 times 4. So we'll rewrite the 3. Minus 2 squared is going to be positive 4, right? And negative base raised to an even power, right? So 3 times 4 multiplied by 4 cubed, which is 64. So this now is 3 times 4 times 64, which is 768. That's your answer for question 3. And finally, let's move on to question 4. Question 4 says minus 5 cubed multiplied by minus 4 squared. So this is going to be minus 5. Again, we're expanding because they ask us to. So minus 5 times minus 5 times minus 5 multiplied by minus 4 multiplied by minus 4. This is not necessary to do in your working when you're working out these questions, but the question asks specifically for it, so we need to answer as the question asks. So minus 5 cubed, negative base raised to an odd power, your answer is negative. And 5 cubed is 125. And minus 4 squared, we have a negative base raised to an even power. So my answer is going to be positive, and 4 squared is 16. So we have minus 125 multiplied by 16, and that gives us minus 2,000. So that brings us to the end of these questions and the end of the video overall. So this was just an introduction to indices. So I hope you understand more of what an index is and how they operate in different questions. The next video, we're going to look at laws of indices, so operations on the actual exponents or powers themselves, and how we can manipulate them if we have the same base operations or operating on each other. So I hope you enjoyed this video. Thank you so much for watching, and I will talk to you all in the next one. Okay, so let's take a look at question 1. This instruction tells us we need to expand the following and then evaluate. So as I would have said before, it's not necessary to expand, but this question specifically asks us to. So we need to expand these indices. So 2 to the power 4 is 2 multiplied by 2 multiplied by 2 multiplied by 2. 3 to the power 3 is 3 times 3 times 3. Then we have minus 1 to the power 5. So minus 1 multiplied by itself 5 times. Right. Now we know that 2 to the power 4 is 16. 3 to the power of 3 is 27. And minus 1 to the power 5 is going to be minus 1. Again, because negative base and odd power means we have a negative answer there. So we have 16 multiplied by 27 multiplied by minus 1, which gives us minus 432. Again, work it out manually or use a calculator. Either one works. Let's move on to question 2. So question 2 says 5 cubed multiplied by 3 squared multiplied by minus 2 cubed. So this is 5 multiplied by 5 multiplied by 5 multiplied by 3 multiplied by 3. So 3 2 times. Multiplied by minus 2 multiplied by minus 2 multiplied by minus 2. right? So we know that 5 cubed is 125. 3 squared is 9. And minus 2 cubed, again, a negative base raised to an odd power is going to be a negative result. So minus 2 cubed is minus 8. And let's work this out. 125 multiplied by 9 multiplied by minus 8 is minus 9,000. And this is your answer for question 2. Now for question 3, we have 3 multiplied by minus 2 squared, so that's minus 2 times minus 2, multiplied by 4 cubed, which is 4 times 4 times 4. So we'll rewrite the 3. Minus 2 squared is going to be positive 4, right? And negative base raised to an even power, right? So 3 times 4 multiplied by 4 cubed, which is 64. So this now is 3 times 4 times 64, which is 768. That's your answer for question 3. And finally, let's move on to question 4. Question 4 says minus 5 cubed multiplied by minus 4 squared. So this is going to be minus 5. Again, we're expanding because they asked us to. So minus 5 times minus 5 times minus 5 multiplied by minus 4 multiplied by minus 4. This is not necessary to do in your working when you're working out these questions, but the question asks specifically for it, so we need to answer as the question asks. So minus 5 cubed, negative base raised to an odd power, your answer is negative. And 5 cubed is 125. And minus 4 squared, we have a negative base raised to an even power, so my answer is going to be positive, and 4 squared is 16. So we have minus 125 multiplied by 16, and that gives us minus 2,000. So that brings us to the end of these questions and the end of the video overall. So this was just an introduction to indices. So I hope you understand more of what an index is and how they operate in different questions. The next video, we're going to look at laws of indices, so operations on the actual exponents or powers themselves, and how we can manipulate them if we have the same base operations or operating on each other. So I hope you enjoyed this video. Thank you so much for watching, and I will talk to you.
Thank you for watching. If you have found this video to be helpful, please feel free to contact us for more information about our classes.
All in the next one.